The broadcast is now starting. All attendees are in listen-only mode.
Welcome to ChemSpark, a simple place for all level of chemistry. So we will like to continue the series lecture of point group. So today is lecture number 6, and our aim of this lecture is to understand the symmetry operations. जो हमारे पास एलिमेंट ऑफ सिमेट्री है उससे क्या ऑपरेशन होगा, कितना ऑपरेशन होगा, वो आज इस लेक्चर का एजेंडा है. ओके, सो आई जस्ट क्विकली राइट व्हाट इज द एजेंडा ऑफ द लेक्चर इज टू find out all the symmetry operations that can be generated rated by a given symmetry element. Now, what exactly are symmetry elements? हम यहाँ पे दो कॉलम बनाएंगे, like elements and operations. The very first operation, the very first element is E, identity. मतलब अगर एक मॉलिक्यूल के पास अगर E देते हैं तो you will get you won't be having any operation but you will get an identity molecule. Okay, मतलब आप एलिमेंट E दो तो ओरिजिनल मॉलिक्यूल ही मिल जाता है. तो इसके लिए ऑपरेशन हम खाली E करेंगे, only one operation, that is E. Now when you talk about Cn, that is principal axis of rotation. For example, let us consider water. Okay, now let me label this as H1 and H2. Okay, now where is the principal axis passing through oxygen. Okay, passing through oxygen. So when you rotate, okay, rotate, this is Cn axis. Okay, Cn axis of rotation. More precisely, it is C2 axis of rotation, because after rotation of 2 times, like first rotation, when you do C1 rotation, which is 180 degree, your H1 will come here and H2 will come here. Okay, when you do C2, मतलब दो बार आप रोटेट करेंगे तो H2 will come in its own original position and H1 will come in its original position. Okay, so हम C2 एक्सिस को या फिर C2 प्रिंसिपल एक्सिस को दो बार ऑपरेट करने पर अपने को ओरिजिनल मॉलिक्यूल मिलता है. तो दिस इंडिकेट्स if it is Cn element of symmetry, that indicates कि अगर आप Cn one time देंगे, Cn two time देंगे, and you continue till Cn time. This Cn time is nothing but equal to identity molecule. So the number of operation is n minus 1. So मतलब अगर आप n minus 1 ऑपरेट करेंगे तो you will get an indistinguishable structure, like it will be not the similar structure which you require, और identity structure नहीं मिलेगा. but हाँ, जैसे आप CNN ऑपरेशन देंगे तो you will get E, identity operation. Okay, so let me erase this. So number of operation is n minus 1 in case of principal axis. Okay, now when you do for sigma, okay, sigma के लिए again I'll take example of water only, HOH1 and 2. Okay, this is one sigma plane and this is one sigma plane. Okay, now when you talk about sigma plane, when you give sigma 2 times, like when you do sigma for this molecule, okay, for this molecule when you do sigma v prime अगर आप देते हो तो your H2 molecule will have image here and H1 molecule will have image here. That means the molecule would be in this format. Okay, and once again if you do sigma v prime, then your molecule will change from 1 2 to 1 1 to 1. You will get the original molecule. That means sigma, if you do sigma square, you will get nothing but E. So that means how many number of operation? Only one, that is sigma. Now I, center of inversion. Let me take a different example in this. Okay. For example, you have a point x, y, z. Okay, and you have to, and this is center of inversion. Okay, point, and now your xyz is moving from center of inversion, say minus x minus y and minus z फॉर्मेट में. तो अब क्या होगा कि वापस से अगर आप उसको सेंटर ऑफ इन्वर्जन लगाएंगे, यू विल गेट योर ओरिजिनल मॉलिक्यूल बैक. This indicates that I square also will give you identity molecule. So in this case, how many number of operation involved is only one, that is I. Okay. Now this is the next operation, next element of symmetry is SN, improper axis of rotation. Now improper axis of rotation is divided into two parts. मतलब कैसा है कि for even it is different and for odd it is different. Okay, now we'll first see what is even and what is odd. Just a sec. अभी सुनने का आएगा तो एंड करके करना पड़ेगा ना. बहुत लिखने का था इसलिए मैंने पॉज कर दिया. हाँ, टाइम ऐसे जाएगा नहीं ज्यादा. Now for even, improper axis में जो even part है, for example s, let us take an example of s4 and 4. Okay, now improper axis of rotation is nothing but Sn is nothing but, you first rotate and then you reflect. Sigma is for perpendicular. Okay, now अगर मैंने एक बार S4, this is for even, एक बार S4 दिया है, इसका मतलब C4 and sigma. Now if I'm doing it for two times improper axis of rotation, that means S4 square. This indicates C4 square and sigma square. But as you know, sigma square is nothing but E. So C4 square into E, which is nothing but C4 square. Okay. अभी अगर आप देखेंगे तो ये C4 square मतलब क्या होता है? It is 180 degree, मतलब 180 degree rotation, which is nothing but equal to C2. For example, अगर आप water molecule को ही देखोगे, okay, वाटर मॉलिक्यूल को ही देखते हैं तो क्या होता है कि ये वाला हाइड्रोजन आटम को यहाँ पे शिफ्ट करने के लिए यू रिक्वायर 180 डिग्री रोटेशन. ओके, 180 डिग्री रोटेशन. ठीक है. अगर आप सिमिलर चीज C4 मॉलिक्यूल में करते हो, C4 मॉलिक्यूल इज 90 डिग्री रोटेशन. तो ऐसे दो बार रोटेशन हुआ 90 डिग्री का, विच इज ऐसे दो बार रोटेशन हुआ 90 डिग्री का, तो दिस मीन्स 180 डिग्री रोटेट हुआ. तो दैट इज नथिंग बट C2 axis of rotation. So whenever it is S4 raised to 2, that means it is C2 operation. Okay. अभी दूसरा, because अभी भी हमें को कंटिन्यू करना है क्योंकि we haven't received E yet, identity molecule. अभी S4 3, this is nothing but C4 3 and sigma 3. now यहाँ पे हम लोग इसको S तरीके से लिख सकते हैं, sigma square into sigma. Now sigma square is nothing but E, which is equal to C4 3 E into sigma. Now E is nothing but 1 unity, तो इसका मतलब C4 3 and sigma is the operation. Now S4 raised to 4 is nothing but C4 raised to 4 and sigma raised to 4. Now Cn raised to n is nothing but E. So this is E. This is E into sigma square, which is also nothing but E into E into E, which is equal to E. So when you talk about even S4 4 improper axis of rotation के लिए even के लिए you require this much operation. यहाँ तक this is the operation, but once it is S44 you will get E. Now we'll see check with odd and then we'll write a summary to it. Okay, now for odd let us take an example of S3. Now Sn is nothing but Cn sigma and S3 is nothing but C3 sigma. Now S32 is nothing but C32 and sigma square, which is nothing but C32 into E, which is equal to C32. Okay. अभी दूसरा S3 raised to 3 is nothing but C33 sigma cube, but this is Cn raised to n, that is nothing but E into sigma square into sigma, which is nothing but E into sigma, which is equal to sigma. S3 raised to 4 is nothing but C3 raised to 4 and sigma raised to 4. This is C3 dot C33 dot sigma square, which is nothing but this is E, this is E, this is E. Then hence it is C3 only. Now S अभी तक E मिला नहीं है, इसकी वजह से हम और एक करेंगे S35 is equal to C35 and sigma 5, which is nothing but C33 C32 and sigma 2 and 2 sigma. This is nothing but law of indices. Now this is E, this is E, this is E, which is equal to C32 sigma. Now S36 is equal to C36 and sigma 6, which is C33 sigma square, which is nothing but this is also E, 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 that means E. So now we got E identity. So that means for odd number of molecule you require to do these many operations. So what would be the conclusion for this? We have to write for even. Conclusion is number of operation Sn1 to Sn minus 1, and for odd is Sn1 to Sn2n minus 1. Okay, so this is for odd and this is for even. So this is basically our number of the aim of our lecture was to find out the number of operations can be done by using these many elements of symmetry. Thank you so much. Stay tuned for next lecture. Yes, तो क्या मेरा अभी कैसे करूँ? जी बहुत गंदा बोला. हाँ, स्टॉप किया. अभी क्या